Okay, so just update your header to whatever it needs to be for your class. Right now when I'm recording, it's pre-cal first period on August 28th. And so our problem numbers are in 4-2, page 209, numbers 5 to 10, 12 to 48, every other even, 45, and 60 to 76, every other even. So the first several are just vocabulary and concept type questions. So number 5, in polynomial division, you have the divisor times the quotient plus the remainder equal the dividend. So remainder and dividend are the blanks, but write that whole sentence. On the next one, it says when a polynomial is divided by x minus c, the remainder is f of c. And so over here I just put remainder is f of c. Number 7, if 4 is a real 0 and it's an even function, then negative 4 is a 0. So there's a picture of it. What you need to do is remember that an even function means it's symmetric to the y-axis. And so that means if there is something on the right, there's something on the left. That's the negative 4 would have been the blank. Remember, you can stop me at any time. I can pause it and explain something as needed. So just let me know. Okay, number 8. The question says it's a true-false type question. I'll put T/F. True-false type question. Every polynomial function of degree 3 with real coefficients has exactly 3 real zeros. It's false because you could have 1 or 3. If you have 1, then you'd have 2 imaginaries. Any questions about that? Okay, number 9. It says if f is a polynomial and x minus 4 is a factor of f, then f of 4 equal 0. 0 would be the blank, but write that whole sentence. If x minus 4 is a factor, then f of 4 equals 0. So what this means is if you have something that's a factor, it's also called an x-intercept. It's also called a 0 of the graph. And when you plug in that number, of course, change the sign. If it's x minus 4, then you put positive 4. If for some reason this had x plus 4, then you'd have f of negative 4. So that'd be equal to 0. So that ties into the notes that we did where it was talking about x-intercept, solution, and root. Any of those words are interchangeable. X-intercept, solution. I just put SOLN to abbreviate, and root. It's also called a 0 of the graph. It's also called a 0 of the graph. So, for example, and we'll get into other problems later, but if, say, you're just graphing something, bless you. If you're graphing something like, let me do x up arrow 3 minus, whoops. Okay, I'm glad I did that. Notice I was doing x to the 3rd power, and then I was trying to do minus. I forgot to move my cursor down, and so it's doing the minus to the exponent. So don't make that mistake. So what I'm going to do is delete that and then go to the right. Then I'm back to the right spot. So if I do x cubed minus 3 it's going to look like that. Okay? And then when we go menu and then analyze graph is number 6, 0 of the graph is the very first item. Okay? So we go 0, then you trap it between the lower bound and upper bound. So between there and there. And in my case, it's 1.44. Okay. Now remember, based on directions, sometimes it may want the square root answer or something else. But I was just showing you the feature of the calculator. Okay. Any questions about that? Okay. Number 10 is another true-false type question. It says if f of 2 equals 5, then you have f of x over x minus 2 is equal to p of x plus 5 over x minus 2. So this is true. The reason is because this 5 would be considered your remainder. And so your remainder goes on top, and what you're dividing by goes on bottom. And in this case, the p is the quotient. The p is the quotient. So in our formula that we saw, it was q of x, but in this one, they just use p of x. Any questions? Okay. Okay, so that was number 10. Now moving on to number 12. Whoops, let me freeze that for a second. Let's see, I don't think so. No, we go 5 through 10, then 12. Okay, good question. Good question. Okay, so on this one, what it says is we have f of x equal negative 4x to the third power plus 5x squared plus 8. And then there's a little semicolon, and it says x plus 3. So on this one, what we want is the remainder. And so if you wanted to do synthetic or long division, you can, but the simpler approach is just to use our theorem, which says basically when you plug in your number, and if you get a 0 for your answer when you plug it in, then it's an actual root. So this is actually a simple one. You just change your sign, you got negative 3, and use your calculator. Do negative 4 times negative 3 to the third plus 5 times negative 3 squared plus 8. We got 161, and so if it's anything other than 0, it's considered not a factor. Okay, not a factor. I also put a little note, or use table. So sometimes you may want to just graph it like negative 4x up arrow 3 plus 5x squared plus 8, enter. So there's the graph, and then you can go to your table. So menu 7, and then since we were interested in negative 3, if I look at negative 3 and see a 0, it'd be an answer, but in this case it's 161. So you can type the regular equation and look in the table at x equal negative 3, or if you just want to use your scratch pad and type that in, either way works. So whatever you feel best at. Any questions? Okay, so this is where we're starting to do every other even, so we're skipping 14 and going to 16. On 16, it's basically the same instructions, but this is a little tricky. The reason is because, as you can see, it goes 2x to the 6th minus minus 18x to the 4th. So right there we skipped a term, which was 0x to the fifth. Remember when we talked about this in the notes, I said be careful about zero terms. So if we were doing synthetic division on this, it would have to look like this. We've got the -3 from there, and we'd have to do 2, 0, -18, 0, 1, 0, -9. And I'm not going to work through that because for this problem we don't have to do synthetic or long division, but this is just my reminder to you to watch out for zero terms. Okay, so what we have to do is plug in the -3 to the equation. In this case we do get 0 when we do it, and so it is a factor. So it is a factor since f of -3 is equal to 0. So that means it crosses the x-axis at x equals -3. Any questions? Okay, number 20. This one has 3x to the fourth plus x cubed minus 3x plus 1. And this time your factor is, well, it says x plus 1/3, so your factor would be -1/3. So on this one, just plug in your -1/3 into all the places for x. In this case, I got 2, and so it's not a factor. Remember, if you get anything other than 0, it's not a factor.
Autumn's mom.
Okay. All right. So that was number 20. So what we're doing, number 24, is determine the max number of zeros and list potential zeros. Okay, so I have a note on C example 3 on page 201. Oh, whoops. Sorry about that. Yeah, I have a note about C example 3 on page 201. So we basically have our function that says 2x to the fifth minus x to the fourth, bless you, minus x squared plus 1. So I'm going to flip over to page 201 for the example. I'll show this again in a second. So the example says listing potential rational zeros, and there's the function. And so it basically involves a p and a q variable, one of which is the front, the other one is the back. Okay, so turning the page to 202, they say p is going to be the factors of -6. So P has to do with the back. P has to do with the back. So you list all your potential ones, and then Q has to do with your first coefficient, which in this case was 2. And so those are your factors of 2. So think of it being 1 times 6, -1 times -6, 2 times 3, -2. Wait, sorry, it's a -6. One of them's positive, the other's negative. Let me just keep it simple. So 1 with 6 and 2 with 3. And then for positive 2, both of them would have to be positive, or both would have to be negative. So that's going to be our first step to write out what the P and Q is. Now we have to form all possible combinations of P over Q. So basically it's a back over the front. So you do 1 over 1, which is 1. -1 over 1 is 1. 2 over 1 is 2. and 3 over 1 was 3, 6 over 1 was 6. So we did everything with the Q value. Then they do 1 over 2, so that's a half. 2 over 2 is the same thing as 1, so you don't write it again. And then 3 over 2 was an answer, and 6 over 2 is 3, which we already had. So that's going to be your potential zeros. So then let's say 2, 4, 6, 8, 10, 12 possibilities. Okay, so that's an example. What we're doing on ours is we have 2 and we have 1. So the Q is 2 because the Q is what's in front. And so factors of 2 would be 1 and 2. You know, both positive and negative. And then factors of P would be 1 because it's just P equal 1. So you have plus and minus 1. Then what we do is we do P over Q. And so this one divided by that one. So 1 over 1 is 1. 1 over 2 is a half. So I wrote it two ways. You could do either one. At first I did plus and minus, and then I just wrote 1 and 1/2, but that might be a little confusing. Plus and minus 1 and plus and minus a half. So there are 4 potential ones. Any questions on 24? So remember, the potential ones are like, say you're a type person that likes to use trace, but you know your potential zeros and you're like stuck at 0.57 on your trace. Well, it would actually be 0.5 because you know that 0.5 is a potential. Any questions? All right. The next one, that shows negative 4x cubed plus x squared plus x plus 6. So what we do to start with is put the q, which is the front, and it's negative 4. So how you get negative 4, this part you don't have to write, but it's basically your tree. You're doing a negative 4. And so you could think 1 times negative 4, negative 1 times 4, and 2 times negative 2. So definitely write your list for the Q. Some people do the tree mentally, so that's why you don't have to write the tree. And then P is 6, which is the back. And so in order to get 6, you'd think 1 times 6 or 2 times 3. So what we're doing is P divide by Q, and so 1 divide by 1, 1 divide by 2, 1 divide by 4. I guess those are all my fronts. And then 2 divide by 1, 2 divide by 2, 2 divide by 4, etc. And 3 divide by 1, 3 divide by 2, 3 divide by 4, and 6 divide by 1, 6 divide by 2, 6 divide by 4. So it doesn't matter the order that you have them in, as long as you get them all done. I guess the year I wrote this, when I said divide by Q, I kept my Q the same. So anyway, it doesn't matter the order.
They're all plus or minus.
Yeah, they're all plus or minus. Thank you. Yeah, I guess I did a shorthand like I started to do there, but this had a lot. So yeah, these are all plus or minus. So we've got 2, 4, 6, 8, 10, 12, 14, 16 potential zeros. 16 potential zeros. But the maximum number that it really had was 3 based on the x cubed. Remember, it could either be 3 or it could be 1 with 2 imaginary. Any questions on 28? Okay, 32. This one, it's negative 6x to the third minus x squared plus x plus 10. So your q value is what's in front, which is negative 6. And so these are my q's. It's 1, 2, 3, and 6. Because it's 1 times 6 and 2 times 3, basically. Again, you don't have to write the tree unless you want to. And then for p is 10. So you can do 1 times 10 or 2 times 5. So again, these are your p values. Here's your tree, but you don't have to write that. But I'm just showing you, if you have a positive 10, it could be positive 1 times positive 10 or negative 1 times negative 10, and so forth. And then you're just doing all your combinations of p divided by q. So we're taking 1 over 1, 2 over 1, 5 over 1, and 10 over 1. So that's what I did to start with from our first row. And then I take 2 over 1, 2 over 2, 5 over 2, and 5 over 2 was new, so I had to write that. 10 over 2 was 5, which we already have. So we try not to do duplicates. And then 5 over 1 we already had. 5 over 2 we already had. 5 over 3, that's new. And 10 over 3. And we also had the 1 over 3 and 2 over 3. Yeah, those are your 4 for dividing by 3. And then when we divide by 6, it's 1 over 6. 2 over 6 is the same as 1/3 when you reduce your fractions. 5 over 6, which is new, and 10 over 6 is the same as 5/3. So those are all your zeros. And so that one had 24 potential. 24 potential zeros, even though there's only a max of 3. So what y'all would want is you'd want a small p and a small q. Because the bigger q and p are, the more potential zeros there are. Any questions? Okay. The next one we have is 36. So this one is about bounds on zeros. And so we have f of x equal 2x to the third minus x squared minus 11x minus 6. So these are the steps for the bounds. We want to know like what the x minimum and x maximum are. That's the whole point of doing bounds. It's like, what should your window be? Now, most people don't like this problem. I tend to agree with them, but it's in the curriculum. Because it's like, if I don't see what I want, then why can't I just zoom out? So I get it for this one. But this is like something I'm supposed to teach you.
So it's just like finding the max and min?
Yeah, find the x max and x min on the calculator. Like, in other words, if I get rid of this table, they may say, if all you have is 2, then, you know, maybe this is too wide, and so you should say something like from -3 to 5. So then it's right in the middle. I don't know. That's the point of this one. I don't necessarily agree with it, because it's a whole lot of work just to set a window. It's like, anyway. I mean, really, I'm trying to be real with y'all. Okay, so the first thing we need is our coefficient, and we're supposed to have a coefficient of 1. We need a coefficient of 1, and our real coefficient is 2. So what we do is we divide by 2 to every single term. And so 2 divided by 2 is 1, so we finally got what we want. Then -1 divided by 2 is -1/2. 11 over 2 and 6 over 2 is 3. So that's our first step. Make sure you have the right coefficient. Okay, so then what we need to do is go from right to left, and the lowest is called A0. So A0 is -3, A1 is -11/2, A2 is -1/2, and A3 is 1. So on this, because of the way the formula is, you don't use the highest one, so don't use A3 on this one. Okay, so what we're doing to start with is we have the max, and that's a little curly brace. Sorry, that just moved. Okay, the max between 1 and the absolute value, and you're going to add of every single one. Like the absolute value of -3 would be +3. For this one, you'd have +11/2, and so forth. So that, and then the max between those. I honestly don't see myself assigning this one problem. I mean, in your book it goes from 33 to 38 like this, but I don't see myself assigning this. So this is 1 plus the max between these numbers without the plus. And so basically 5/2 is bigger than 3, and so 11/2 is your max, and you do 1 plus that, you get 6.5. Then once you have your 9 and your 6.5, then you need to choose the smaller one between those two answers, and the smaller one is 6.5. So that means your window should be from -6.5 to +6.5. So that's the whole point of this. I mean, I don't agree with it. It's like, why can't we just use negative 10 to 10? The only time this would be useful is if you have like a very curvy function that goes outside and you didn't like zoom out enough. But anyway, there you go. So again, step 1 was make sure you have a coefficient of 1. Step 2 was make sure you have your A's listed. Step 3 is do your max of between 1 and the addition. So between 1 and 9, 9 was biggest. So that's why we chose 9. And then step 4 was you do your 1 plus max of those without the plus. And so 5.5 was biggest. So then you do 1 plus 5.5 is 6.5. And then you do the smaller, which is the minimum, between 9 and 6.5, and it's 6.5. So that's your step. I'm going to pause right there for just a second. Okay, so what I'm going to do is I'm going to remove number 37 from your Math Excel, if possible. I think since everybody's already started the Math Excel, just put in negative 10 to 10 and I'll count it right. So it's a lot of steps just for a window. Okay, so number 40. Number 40 says find the real zeros. Okay, and this is actually the purpose of the whole lesson. Find your zeros. Okay, so this one we have f of x is equal to x cubed plus 8x squared plus 11x minus 20. Now notice I put the little note, if q is equal to 1, then it's easy to get your answers. And you can just use your calculator to graph it, and you see negative 5, negative 4, and 1. And so in the table, that's another way to look at it. It's negative 5, 0, negative 4, 0, and 1, 0. So those are your real zeros. And this would be the factored form of it, just changing the signs.
So if it has a coefficient of something other than 1, can we not just graph it?
You can, but you might have to get like a fraction, or yeah. So in other words, it wouldn't be an integer, which was easier. Okay, 44 is going to be our last one for the day. We've got f of x is 3x to the third minus 7x squared plus 12x minus 28. On this one I put still use the calculator, even though there's like a 3 in front. You can see that it's 2.33, which is 2 1/3, and you got to make that 7/3. So that means x minus 7/3 is a factor. In other words, your first step on this is use your calculator, and then from there either use your calculator again if possible, or if you can't, then you either have to use synthetic division or long division using this c value. So we've got an x minus 7/3. You don't have to write both methods. If you want to do synthetic, you can, or if you want to do long division, you can. You don't have to write both methods. So remember, when you're doing synthetic division, you take your coefficients and then it involves adding. So this is a little plus sign. Synthetic division involves using your plus sign. So you bring down your 3, and then you go 7/3 times 3, and you get positive 7. Negative 7 plus 7 is 0. 7/3 times 0 is 0. Then you bring down your 12. 7/3 times 12. I would do 12 divided by 3 first, and you get 4. 4 times 7 is 28. So this is not 10. This is like a little placeholder thing. Like, that's your remainder. If you get a 0 remainder, then it was a factor. And so what we have based on our answer is 3x squared plus 0x plus 12. So then what I did is I factored out a 3, and that's that part of it. And so you have your 3 factored out, and then you have your x minus 7/3 from the top, which was the first factor. And then this other is the irreducible quadratic factor, which is x squared plus 4. And so they have it as 3x minus 7 times x squared plus 4. Don't distribute to both of them, like to this term in parentheses as well as this. That would mess things up. I just distributed to the first one, so then that's your answer. And again, if you'd rather do long division, which implies subtraction, you can. Just make it work out, and then you end up with a 0. And so x squared plus 4 is your quotient. So again, that's your answer. Okay, so that's going to be our stopping point.